This is a talk through of the GCSE Chemistry Unit 1 higher tier paper. It's the specimen paper and it was timed to be 1 hour 15 minutes long and the total mark 80 marks. Question 1. Gold is the most malleable and ductile of all the elements. What is meant by the word malleable? Straightforward definition just to start off. So it just means it can be hammered into shape. Okay. State the name and number present of each particle in the nucleus of a gold atom. This is your first opportunity to look it up on the data sheet. Obviously you get your periodic table with the exam, so make sure you use it. So there are 79 protons and 118 neutrons. And just to explain where I got that from, the mass number is 197 and the atomic number is 79. So 79 protons, take one away from the other, you get 118 for your neutrons. 1 mark for each of those. Then state the approximate radius of the nucleus of a gold atom. Give your answer in standard form and state the units. So the answer is 0.1 nanometers, which in standard form is 1 by 10 to the minus 10 meters. Pure gold is very soft and is often alloyed with other metals such as copper or silver for use in jewellery. Explain in terms of structure why an alloy is harder than a pure metal. So what I want to say here is that in an alloy, different sizes of atoms are present. And then that makes it difficult for the layers to slide over each other. So 1 mark for stating each of those parts of the answer. Now the next bit, carats used to be on the syllabus, not anymore, but a carat, it's if you have 100% pure, it's 24 carat. So 21 carat gold would be 21 divided by 24 times 100. So the answer is 87.5%, but as I say, that has been removed from the syllabus for a while now. So explain why white gold is a formulation. So formulations are on the specification, and what you need to say there is that a formulation is it's a mixture, but it's different substances mixed. The thing about a formulation is that it's in measured quantities. And it's to make a desired or useful product with the required properties. So again, we have 2 marks for that. So 1 mark for saying about the different substances mixed in measured quantities, and then for the required properties is your 2nd mark. Finally, in this question, gold is a very unreactive metal. However, it will react slowly with chlorine gas at room temperature to form gold 3 chloride. That's the important bit there, the 3. So we just are going to say Au for gold. So write a balanced simple equation. So plus chlorine is Cl2. And then gold 3 chloride, so that would be AuCl3. And then, so you get 1 mark for the reactants, 1 mark for the products, and then your 3rd mark is for balancing it. So looking at this, we have 3 chlorines. The only way we're going to get anywhere with that is just to put a 3 in front of the chlorine molecule, and that means then we're going to need a 2 there and 2 in front of the gold. So 1 mark for the balancing. Okay, question 2. The compound calcium carbonate makes up about 7% of the Earth's crust. It occurs in a variety of mineral forms, including limestone. What is meant by the term compound? Lovely question. So you're just going to say 2 or more elements chemically combined. When calcium carbonate is heated, it thermally decomposes as shown in the equation. So CaCO3 gives you CaO and CO2. So then describe a chemical test to prove that carbon dioxide gas is produced in this reaction. So they're looking just for 3 things in this, and it is that it turns lime water from colourless to milky. So 1 for each of those points in the mark scheme. Then calculate the mass of calcium oxide in grams, which is produced when 15 kilograms of calcium carbonate is thermally decomposed. So I'm just going to keep the balanced equation up there in sight. So we can see that it's a 1-to-1 ratio. So just looking then to work out how many moles of calcium oxide are produced from this 15 kilograms of calcium carbonate. The first thing to do is to change the 15 kilograms into grams. So 15 times 1,000, which is 15,000 grams. And then we just do number of moles is mass divided by the formula mass. So the mass is 15,000. The formula mass of calcium carbonate is 100, and then so if we get 150 moles, and then we have to work out, so 150 moles of CaO is 150 times the formula mass of calcium oxide, 40 for the calcium, 16 for the oxygen, 56. So that gives us 8,400 grams is your answer. So next, this is an empirical formula question. Calcium carbonate is also found in the mineral dolomite. Dolomite contains 21.74% calcium, 13.04% magnesium, the same of carbon, and 52.18 of oxygen. The way I would do this is just to write the elements to begin with, so calcium, magnesium, carbon and oxygen, and then the percentages underneath. So 21.74, 13.04 for both the magnesium and the carbon, and then 52.18 for the oxygen. Then I write in the relative atomic mass of each. So 40, 24, 12 and 16. And don't forget to use your periodic table to check these. And then we divide each one through by its relative atomic mass. And we get 0.5435 for the calcium, 0.543 1.0866 for the carbon, and 3.26125 for oxygen. Then we divide by the smallest, So the smallest in this case is this. I'm going to say they're basically the same number. So we're going to have 1, 1, then we get 1.99 here and 6.0. So I'm going to round that up to 2. So our ratio is 1 calcium, 1 magnesium, 2 carbon and 6 oxygen. So the empirical formula then is CaMgC2O6. Next one, in an experiment to find the percentage of calcium carbonate in a sample of eggshell, 1.25 grams of eggshell was added to an excess of hydrochloric acid and 0.0075 moles of gas were produced. Calculate the mass of calcium carbonate in grams present in the eggshell sample. So we're looking at the equation here, and we have 1 mole of calcium carbonate for every mole of carbon dioxide. So we know that we have 0.0075 moles of gas, which means we also have 0.0075 moles of calcium carbonate present in the sample. So we're looking here to use the formula. Mass is the number of moles times the formula mass, which is just rearranging number of moles equals mass over RFM, which is going to give us 0.0075 times 100, which is 0.75 grams. Part 2, calculate the percentage by mass of calcium carbonate present in the eggshell sample. So you're using this equation. We've got percentage is the mass of the calcium carbonate over the mass of the eggshell. And we're told in the question here that it's 1.25 grams of eggshell. So that's 0.75, which you've just worked out, divided by 1.25 times 100, which gives the answer of 60%. And if you get that one wrong, they would implement an error carried forward there. So you still would get the mark even if you got the previous question wrong. Now, number 3, fish are sensitive to pH, and different types of fish survive in solutions of different pH ranges as shown in the table. Complete the table by deciding if the pH range suitable for each fish is acid or alkali, and also if it's a strong or weak acid. So really, you don't need to worry about the type of fish here. You're just looking at the pH range and can you recognise, is it acid or alkali, and is it strong or weak? So we can see that these two below 7 are both acid, and they're both weak acids. And then this one is an alkali because it's above 7, and it is a strong alkali. No, that's not. It's a weak alkali as well, apologies. So they're all weak. The brown trout survive better in acid, the orange sea perch in alkali, and the tiger barb in acid. Then it says salmon survive in water which is pH 4.9 to 5.5. State and explain if this water has a higher or lower concentration of hydrogen ions than the water in which the brown trout survive. So if we look at the brown trout here, we're looking at between 3.5 and 4.5. And this number is 4.9 to 5.5. So that's actually closer to neutral, so it's a weaker acid. Which means, so I'm going to say here, the pH of 4.9 to 5.5 has fewer hydrogen ions. Because a lower pH is actually equal to a higher concentration of hydrogen ions. So 1 mark for saying fewer and 1 mark for then, as you're stating fewer, and then explaining is that the lower the pH, the higher the concentration of the hydrogen ions. Well, I've just done something here which I would really hope you know not to do in the exam, which I've gone outside the space that the question is supposed to take. If you do run out of space in the lines allocated for a question, please go onto a spare page, right? Write the question number clearly and indicate that you've done that, because when these papers are scanned, very often they just take the area that the question is the answer is supposed to fit into, and if your answer has gone down onto the bottom of the page or something, the examiner who's marking it may not actually see it. So just to make sure you do get all the marks you're entitled to, do everything that goes outside that space on a separate page and mark it clearly so that they can see it when they're marking. Part B then is asking you to interpret some data. We've got this big graph. It says fish produce ammonia in their waste products. The build-up of ammonia in a fish pond can harm fish. The graph shows the percentage of ammonia present in pond water against pH at different water temperatures. So you see the ammonia present is on the y-axis and the pH is on the x-axis. So use the graph to determine the relationship between the pH of the pond water and the percentage of the ammonia present. So you can see this very clearly here in all of the graphs as the pH increases, the amount of ammonia present increases as well. So we're just going to say very simply that as pH increases, the percentage of ammonia also increases. Then use the graph to determine the relationship between the water temperature and the percentage of ammonia present. So here we see the water temperature increasing as we go up, and you can see then clearly that the higher the water temperature, the higher the percentage of ammonia. So as temperature increases, the percentage of ammonia also increases. Okay, just one mark for each of those. And it says small amounts of sulfuric acid can be added to remove ammonia from pond water. Write a balanced symbol equation for the reaction between ammonia and sulfuric acid to produce ammonium sulfate. So again, there's going to be 1 mark for the reactants, 1 mark for the products, and then 1 mark for balancing it. So we've got ammonia and sulfuric acid. So ammonia is NH3, sulfuric acid is H2SO4, and then it's forming ammonium sulfate. Now look, if you're not sure about the formula for ammonium, look it up in the data leaflet, and the same for sulfate. So it's actually going to be NH4 twice SO4. So then to balance that, we need a 2 in front of the NH3. Okay, so 3 marks, 1 for the reactants, 1 for the products, and 1 for the balancing. Next, aquarium salt is often added to fish tanks to reduce the number of disease-carrying organisms. Its main ingredient is sodium chloride. Sodium chloride is prepared in the laboratory by the neutralization reaction between hydrochloric acid and sodium hydroxide. So what is the general name given to a soluble base such as sodium hydroxide? Nice easy one. It's just very simply an alkali. Then write an ionic equation for neutralization. Include state symbols in your answer. So this is one you should have learned just straight out of your notes. It's not asking you for this neutralization here, it's just for neutralization. So it's H plus AQ plus OH minus, which is also AQ, and that gives you H2O, which is a liquid. And again, 3 marks, 1 for the products, 1 for the reactants, and in this case 1 for the state symbols. Describe how you would experimentally prove that aquarium salt contains sodium chloride. So you're looking for 2 tests here, 1 for sodium and 1 for the chloride ion. So you would use a flame test and that's for the sodium, and the result would be yellow is sodium. So one for saying you'd use a fluent test and one for saying the result is yellow for sodium. Now, you may be tempted to say it's an orangey yellow or yellowy orange. Don't do that. See it, accept yellow as the colour of the sodium flame. That's what you write. And then for the chloride ion, you're going to just say that you add silver nitrate. And that's going to give a white precipitate for the chloride. So we should remember those precipitates for the halogens. Chloride is white, bromide is cream, and iodide is yellow. And that's your 4 marks there. Then the presence of aluminium ions in water can harm fish. It collects on the gills, reducing blood oxygenation. Name a solution which can be added in excess to water to remove the aluminium ions by precipitation. So it's just sodium hydroxide. So aluminium hydroxide is insoluble, and that's why that works. The equation then for the precipitation reaction, so we're looking for the Al3 plus, which is the aluminium ions, plus hydroxide ions, is going to give us the aluminium hydroxide, AlOH3, and then to balance that up we need a 3 at the OH. So again, 1 mark for the reactants, 1 for the products, and 1 for balancing. You see a theme emerging with these equations and how they're marked. Okay, number 4. The names of some alkali metals and some halogens are shown in the table below. We've got lithium, sodium, potassium, fluorine, chlorine, and bromine. All halogens react with alkali metals to produce a salt. So explain in terms of electronic structure why the halogens undergo similar reactions. So what? Obviously electronic structure, we're thinking about the outer shell. So all are in group 7. So we'll have 7 electrons in the outer shell. Using dot and cross diagrams, explain how lithium fluoride is formed from atoms of lithium and fluorine. Include the charge on each ion formed. So we're going to draw little dot and cross diagrams then for lithium and for fluorine and then for lithium fluoride. So starting with lithium, again you can look it up in the periodic table that you get in your exam. So we've got 3 electrons, and for fluorine we have, I'm doing these as dots, so there are 7 in fluorine's outer shell. Okay, so 9 in total for fluorine, so that's lithium and that is fluorine. Now what I'm going to show here is that this outer electron goes to here, and actually I did a mistake there. I drew 8 on the fluorine, so there should just be 7 on the outer shell. And then the next step is to show that the ions have formed. So lithium plus charge is the lithium ion Li plus, and then the fluorine becomes, let me draw that again, I did an X by mistake. The fluorine becomes fluoride, and this is when it has the 8 electrons in its outer shell. I'm going to do one of those as an X, square brackets, and the minus and the F minus underneath, and of course the electrostatic attraction is what holds those two together. Then it says write the formula of the product formed in the reaction between the most reactive alkali metal and the most reactive halogen from the table above. So looking at the table, the most reactive alkali metal is potassium and the most reactive halogen is fluorine, so it's potassium fluoride. So KF, both have a valency of 1, so just react in 1-to-1 ratio. So that's what you get. Now, next we're looking at quite a long question about bonding. It says explain why chlorine is a gas at room temperature but lithium fluoride is a solid at room temperature. So what we need to be saying here is talking about chlorine first. So chlorine has weak intermolecular bonds. And those are the only bonds that exist. And they are van der Waals. So that would get you 1 mark. And the second mark is for saying these require small amounts of energy. To break. So that's 2 marks. Next bit we're going to talk about sodium chloride then. So it has strong ionic bonds. That will get you 1 mark. And these require large amounts of energy to break. So that's your 4th mark. Oh. Okay, so chlorine has weak intermolecular bonds, the van der Waals, and those are between the chlorine molecules, and they just require small amounts of energy to break. Sodium chloride has strong ionic bonds, of course it's in a giant lattice, and requires large amounts of energy to break those bonds. Next, describe and explain. So describe will be 1 mark and explain will be 2 marks here, because it's out of 3. The trend and reactivity of the alkali metals down the group. So describe is really just stating what it is. So reactivity, as you know, decrease, or brain's going too fast for my hand. Reactivity increases down the group. So that's 1 mark there. And the reason for that is, of course, that the outer electrons are further from the nucleus. So there is less attraction between that outer electron and the nucleus. And that's what makes it easier to remove that electron. So 1 for talking about the distance from the nucleus, and then the second for saying how that affects the attraction between the electron and the nucleus. Now, I've seen this question come up a couple of times. Compare the chemical and physical properties of the alkali metals with the transition metals. So in your answer you must compare physical properties including melting point and density, and chemical properties including relative reactivity with water and the charges on the ions formed. So it says in this question you'll be assessed on your written communication skills, including the use of specialist scientific terms. So you try and write this in a paragraph. I'm going to do it just as a table because it's clearer to see when I'm doing it this way. So the transition metals and then the alkali metals. I'm going to start with the first property, which is melting point. So for the transition metals, it's a high melting point. And for the alkali metals, low melting point. The transition metals then have high density. Think of something like titanium, which is used for, replacement joints in your body. It has to be high density. The alkali metals are low density. If you remember, they float on water. The transition metals have low reactivity, so that was the melting point density, then the chemical properties, so reactivity first. So transition metals have low reactivity, where the alkali metals have high reactivity. So you think the difference between something like gold or silver or copper and then potassium is quite significant. So it's reactivity with water. And then the charges on the ions formed. So of course the alkali metals only form +1 ions. That's all they can do. Whereas the transition metals, as you know, the ions can have different charges. So you'll see from this that there are a maximum of 8 points that you could get. Well, 8 indicative points. So the way that this is marked then, if you have between 6 to 8 ticks, you get 6 marks. 4 to 5 ticks, you get 4 marks. And if you have between 2 and 3 ticks, you get 2. If you have fewer than that, they would deem your response not worthy of any credit and not give it any marks. Also, the use of specialist scientific terms, so you need to be using the words like melting point, reactivity, density, and so on in the answer that you're giving. Number 5, carbon is an element with atoms with different mass numbers. What is the name for atoms of the same element with different mass numbers? Again, another lovely wee simple question, but it's isotopes. And of course, I've seen that many times asked the other way around. So what is the definition of an isotope? Now, use the information in the table to calculate the relative atomic mass of carbon to 1 decimal place. So we've got mass number 12, abundance 99, and 13 is 1. So we're just looking at then the first mass times its abundance added to the second mass times its abundance, all divided by the total abundance, which is 100. So 99 plus 1 is 100, and that gives us 12.0. Next, carbon burns in air to produce carbon dioxide. Complete the table below to give information about the bonding in carbon dioxide. So first of all, a dot and cross diagram showing outer electrons only. So we have our carbon in the middle and then 2 oxygens. And I'm going to label them like so. Carbon has 4 electrons, so it shares 2 of those electrons with each oxygen, and then the oxygen has 6 electrons, so we're going to have 2 lone pairs here, and then 2 in the overlap of the bond, and then the number of lone pairs in the molecule. So you see here 1, 2, 3, 4. It's asking for lone pairs, not pairs or bonding pairs. So the answer there is 4. Next it says graphene is an allotrope of carbon. Name 2 other allotropes of carbon. Dead easy, diamond and graphite. Be prepared for all sorts of questions about diamond and graphite. It's one the examiners really, really love. And finally, complete the table to give the information about graphene. So the type of bonding is covalent. The type of structure is giant covalent. You could say macromolecule, but it's good always to use the type of bonding in the structure. And does it conduct electricity? Yes, it does. So 3 marks for that. And that brings us to the end of the paper.